Hello everyone, thank you for tuning in. Today, I'm going to present some laser parameters that you can measure and why you might want to do this. I'm Myriam from Gentec-EO, your partner for accuracy. You've got a new laser and you want to do some quality control on it, but you don't know where to start. Let me present some parameters that you might be interested to measure. Average power is a good place to start. You can see this parameter as the strength of the laser. The more powerful the laser, the deeper it can cut or weld metals. Therefore, adjusting the power to the correct level will make sure that you are able to complete your laser process and that you don't waste too much electricity or damage the piece with too much power. Energy can be measured for pulsed lasers only. Measuring the average power can still give you information on the laser, but power detectors are relatively slow, so you need to have quite a big variation in the energy to be able to see it on the power detector. In order to know if the energy of every pulse is stable, you need to measure the energy of the laser. Not all pulse lasers require energy measurements. It is usually seen in applications that require fine-tuning of the energy, like the medical field, where every single parameters need to be controlled. Wavelength is a key parameter since an application can be more or less effective depending on the wavelength used. Every material will absorb wavelengths differently, so you want to choose the correct one. However, most applications will only require you to choose the correct wavelength for the manufacturer, not actually measure it. Repetition rate is the number of pulses during a second. Again, not a lot of applications require this measurement, unless you want to predict exactly when the pulse will happen. The easiest way to measure the repetition rate is to measure the average power and the energy per pulse, and then calculate the repetition rate, since the repetition rate is the average power divided by the energy. Beam size is useful to know how big the laser beam is in your process. Most applications require to measure the beam size at the location we call the waist, since it is the place the beam is the smallest. Beam size is useful to know exactly what area of the material will be affected by the laser. Divergence is the parameter that describes how much the beam size of a laser increases with the distance. The most common need to measure this is free space communication, since the laser light travels a long distance and you want to predict the size of the beam at the location where it is detected. Other applications that require divergence measurement all have a part of the laser beam in free space. Beam profile measures the power distribution in a laser beam. It is useful to know if the beam has hot spots where the power is concentrated and would cause unexpected damage to the material. One industry where the beam profiling is often needed is a type of 3D printing called laser powder bed fusion, since powders need to be melted just right to get the best results. This means the power distribution needs to be adjusted. Some welding applications use some ring-shaped beams that need to be monitored to make sure they have the correct profile. These are the most common laser parameters that can be measured, but there are plenty of others that could be useful for less common applications. If you have a specific need, feel free to contact your local Gentec-EO representative. We'll be happy to help.